Hello everyone, I am Hannah Jasmine Santos and welcome to my YouTube channel. So for today's video, we will perform all the basic logic gates using Logic Gate Simulator or simply LOGAS. So what is LOGAS? So LOGAS is an Android application where you can build and simulate digital circuits right in your hand. It is good to use for every student and teachers that wants to simulate their logic gates or digital circuits because LOGAS is extremely simple and easy to use. So for this activity, we will use a software called Visor that lets you view and control your Android in your PC or in your desktop. And also Bandicam, which used for screen recording and webcam capturing. Now let's go to build and simulate basic logic gates. So this is what you see after opening the LOGAS application in your Androids. As you can see, there is a setting and the plus sign. So we will click this plus sign to create. So there's a file name and templates, and we will name the file as NAND Gate, and we will choose the blank template. And after you set this, you will now click the check sign, and we will go to this template, and in the top you can see the plus, the undo sign, the save sign, and the play sign when we run the simulation later. So we will click the plus sign. So here you can see logic gate, input, output, flip-flop, and text label if you want to add on text label. So we will go choose the logic gate. We will use, so there is 7 different basic logic gates. We will choose first the NAND gate, and we will choose now the input. So here in input, you can see the high logic, low logic, toggle switch, push button, and the clock. So we will first use the toggle switch. We will use 2 toggle switch. And also we will put an output. So there are red, green, yellow lamp and 7 segments. We will choose the green lamp as the output, and after that you will connect the output to the logic gate, and the input you will connect it by clicking it. And after that, we will now run the simulation. We will simulate it now. And so in NAND gate, it says that output is at logic 1 when and only when all its inputs are at logic 1. Otherwise, the output is at logic 0. So let's try it. The A and B is 0 and the output is 0. And when we turn on the other one, the output will be 0 too. We will try the other one. There's no light. But when we turn on this 2 toggle switch, the output will be 1. Now we will stop the simulation and we will save it. After we save it, we can check this in this file name and we can run it again. So now let's go to the second logic gate, which is OR gate. So we will create another one. We will find it as OR gate. We will choose again the blank template and check. So here you can see the OR gate. We will create, we will put 3 OR gates. Sorry, here in logic gate, OR gate again. So for input, we will choose now the high logic and low logic. So we will put 0 and 0. So in the second one, we will choose high logic and low logic. And in the third one, we will choose 2 high logic. We will drag it. You can drag it by clicking it. You can drag wherever you want. Input again, high logic. So after that, we will choose now an output. So I will choose the red lamp. 3 red lamp. Okay. 3 red lamp. And we will connect it to each other. So we can run it later. After that, as you can see in the truth table, it says that in OR gate, the output is at logic 1 when one or more of its inputs are at logic 1. If all the inputs are at logic 0, the output is at logic 0. So let's try it. When we input to 0, says the output will be 0. So let's run it. Okay, as you can see, in 0, 0, the output will be 0, and if one of the input is 1, the output will be 1 or on, and here the input is 1 and 1, A and B is 1 and 1, and the output will be 1 also. So let's stop the simulation and save it, and then we can choose the OR gate, so it will be saved, right? And now we will go to the NAND gate. So we will create new for NAND gate, the third logic gate we will use. We will set the file name as NAND gate. And choose the blank template again and check. And now we will choose the NAND gate. So here in NAND gate, it says that output is at logic 0 when and only when all its inputs are at logic 1. Otherwise, the output is at logic 1. So let's try it. NAND gate. So you can see in the table. NAND gate. So for the input, we will choose, for the input, we will choose toggle switch again. So for NAND gate, it is the opposite of AND gate. You will see it later when we run this simulation. Okay, so we will now put an output, yellow lamp. Let's try the yellow lamp. And we will connect it. After that, we will run this, and as you can see, when A and B, when the both toggle switch are off or 0, the output will be 1. And when we turn on this, the output also will be 1, will be on. The lights will be on. Let's try for this one. But when the two toggle switch is at 1 or on, let's try, let's see, the output will be 0. The yellow lamp will be off. Okay, let's stop this and save this NAND gate. You can see there's NAND gate here. When you click it, save. So let's go to the other one, which is XNOR gate. Let's create new one and let's name it as XNOR gate, and click the blank, check, and in this one we will put a NOR gate. So here in NOR gate, it says that output is at logic 0 when one or more of its inputs are at logic 1. If all the inputs are at logic 0, the output is at logic 1. So let's try it. NOR gate. Okay. So our input will be high and input and 0 and the other one So as you can see, let's run it. No, we will choose the output. Excited. The output, green lamp, yes. and we will connect this one. Excited to run. Huh? Okay, so again, when A and B, when the inputs are 0, the output will be 1 or on. And when the two inputs are or have 1 or on, the output will be 0 or off. Okay, let's run it. Okay, as you can see here in the top, the first one, the output is off or 0 because there is a 1 in here in our input. But here in the second one, the output is on. The lamp is on because our input is 20. The A and B is 0. Okay, let's try when we input the 1 and 1 input. Okay, let's click it and delete. And now we will input 1. Let's see if the output will be 1 or 0. Okay, let's run. So here, as you can see, the output of 1 and 1 is still 0 or off. Okay, let's stop it and save it. NOR gate. In the NOR gate, okay, save. Now let's move on to the NOT gate. So what is NOT gate? Okay, to name it first. NOT gate, and we will press the blank and check. So the NOT gate will be this. So it says that NOT gate is the simplest possible gate that can be called inverter or a NOT gate. It has just one input and the output is its opposite. If the input is high or 1, the output is low or 0, and vice versa. So let's try it. Okay, let's input 1 and output green lamp, and we will connect this one. So after that, let's run. As you can see, when the input is high or 1, the output will be low or 0. So let's stop and let's delete this one. Let's try the 0 input, low logic 0. Sorry, let's drag it here and connect this. So when we run it, it is basically, of course, it will be turned on. The lamp will be turned on because the opposite of 0 is 1 and high or on. Okay, it is C in the truth table. Let's stop it and save. Okay, and now let's go to the next one. So there will be last 2 logic gates that we will perform. So let's start again with the XOR gate, and let's choose the blank. So XOR gate, you can see here this one. So in XOR gate, we will say that output is at logic 1 when one and only one of its inputs is at logic 1. Otherwise, the output is logic 0. Okay, let's try it. you can see the truth table. So we insert our input. We will try now the push button. To push button. And for the output, here is the green lamp. We will connect this one to this one, and this one, and this one. So after that, we will run this, and let's see. Okay, as you can see, our input is 0. This is 0 or off or low. This is also off. But when we click one of these, what will be the output? Because it says that in XOR there must be one and only one input for the output will be 1. So the output will be 1 when there is only one and one input. Okay, let's see. Let's turn this on. Let's push the button. Okay, and the output will be 1. Let's try the other one. The output will be 1. Here 1, and this one is 0, so the output will be 1 because there is 1 in this input. Okay, let's stop. But let's try if the input is all 1, because here in push button we can do that. We can do the same thing at the same time. So we will delete this one. So here in input we will choose this one or high logic, and we will try this one. What will be the output if the A and B input is 1? So the answer is the output will be 0 or off. Okay, so let's stop this. Let's save it. As you can see, this is the XOR gate. Okay, let's go to the last one, which is XNOR. Okay, let's name it as XNOR. Gate. Let's just blank and check. So this is the illustration of XNOR. There is a bubble in there, the small circle. So let's try. So what is XNOR? So it says that in XNOR gate, output is at logic 0 when one and only one of its input is at logic 1. Otherwise, the output is logic 1. So it is the opposite of the XOR. Okay, let's try this one. So let's use the push button. Earlier in the XOR, when the push button is off or 0, the output is 0. But here in XNOR, when we put the two input at 0, the output will be 1. So let's try. Output, red lamp. Let's try the red lamp and connect this one. Okay, and now we will run this. Okay, so the output is high, on, or 1. it's the same thing. The red lamp is turned on when the two inputs are off, or low or zero. Okay? And now when we push the one button, the output will be 0. Okay, let's try the other one. The output will be off, or 0. Okay, do you get it? Let's save it. Okay, let's done. So now we will try to create combination of two logic gates, which is NAND Gate and OR Gate. So let's try. Let's create. We will name this file as NAND and OR Gate. Okay, it's just a blank, and let's check. So here in the logic gate, we will use two NAND gate. Two NAND gate and one OR gate. Okay, and we will input two toggle switch. And the output is green lamp, so we will connect this one. After we connect this one, we will now use first the text label to identify our inputs. We have letter A, letter B, C, D. A. Here, this is our A. Letter B in this part. So our letter C will be here. Our letter C, and our letter D okay here. So this NAND gate, which can be called also as inverter, as I said earlier, that if our input is 0, the output here will be 1. Okay? Okay, let's run it first. Okay, as you can see, our final output, our lamp is turned on, or it is at logic 1, because here in letter A, our input is 0. So here the letter C will be 1, and here also letter B is at 0, so letter D is at 1. So in OR gate, it just simply say that the output is at logic 1 when one or more of its input are at logic 1. So our input needs to be have one or more logic 1. Okay, so here, as you can see, this letter C is 1 and this letter D is 1, so the output will be 1. Okay, so what if we will turn on this letter B? As you can see in the truth table, the letter A is 0, but the letter B is 1. What will happen? The final output will be turned on also, because here our input is 0, the letter C is 1. And in letter B, our input now is 1, and the letter D is 0. 1, 0. And in OR gate, it only needs 1 or more 1. For the output will be 1. So here is 1 and 0, the output will be 1 or on. Okay? It's the same thing when we turn on letter A. Okay? The output also will be turned on. But what if letter A and letter B will be 1 or will be turned on? Okay, let's try. Okay, our final output will be at logic 0 or off, because here in letter A we input 1, and in letter C it will become 0. Same thing with this, we input 1 in letter B, and the NAND gate simply says that it invert the inverter. Okay, so when we input here the letter 1, the output will be 0 in letter D, and C and D now is 0. And in OR gate, it should have at least 1, so the output will be 1. But here in this case, the letter C and letter D is at 0, so our final output will be off or 0. Okay, so let's stop and let's save it. We can click it again, so it's saved now. So that's all. I hope you learned something new today, and don't forget to subscribe and like this video. Thank you.